Okay, let's take a look at problem 17. We have the expected value of x is given to be mu1, standard deviation of x is sigma 1, expected value of y is sigma 2, standard deviation of y is sigma 2, and we're given the correlation is rho. And we have this very complicated function, expected value of y minus its mean minus t times x minus its mean squared. Okay, the interpretation that I want you to keep in mind for this as we're going along is that this is basically, t is going to be a slope that we're solving for. So this is kind of like a run, that's kind of like the rise. And the question is, what's the slope to make this expected value as small as possible? So this is like finding a regression line for a bunch of data. So there's my function. Well, let's write it out better. If I expand this out, that's going to be the expected value. So let me square this out. We have y minus mu2 squared minus 2 times t times x minus mu1 times y minus mu2 plus t squared times x minus mu1 squared. Okay, so let's split this up. We have expected value of y minus mu sub 2 squared minus 2 times t times the expected value of x minus mu1 times y minus mu2 plus t squared times expected value of x minus mu1 squared. Now I could expand this out even further. However, I know full well that that is my definition for a variance. This is the variance of y, the expected value of y minus its mean squared. So if I were to expand this out, I would exactly get the variance of y. Over here I have minus 2 times t. This is my definition of the covariance of x and y. And here I have plus t squared. And this last part here is the definition for the variance of x. So there's my function f of t. Let's minimize it. To minimize it, let's take the derivative. So I get negative 2 times the covariance of x and y plus 2 times t times the variance of x. Set it equal to 0 and solve for t. So 2 times t sigma 1 squared equals 2 times the covariance of x and y. And so t will be equal to the covariance of x and y divided by 2 sigma squared. Now the covariance, I'm sorry, I forgot that the 2's cancel, there's no 2 down there. The covariance is equal to the correlation times the product of the two standard deviations. And so this will be equal to rho times sigma 2 over sigma 1. And so this will be the value of t, the slope of the regression line, that minimizes the function f of t, that minimizes the squares of these residuals. Okay, number 2, let's calculate that minimum value. So let's actually plug in f of rho sigma 2 over sigma 1 and see what we get. And I'll plug into this line right here, sigma 2 squared minus 2 times rho sigma 2 over sigma 1 times the covariance of x and y. And the covariance I know is rho times sigma 1 times sigma 2 plus t squared, rho squared sigma 2 squared over sigma 1 squared times this sigma 1 squared. Okay, can I simplify this? Well, sigma 1 cancels here, sigma 1 squared cancels here. So I'm left with sigma 2 squared minus 2 rho squared sigma 2 squared plus rho squared sigma 2 squared. So that's equal to sigma 2 squared minus rho squared sigma 2 squared, or sigma 2 squared times 1 minus rho squared. And so that matches the formula that we're supposed to get. And from statistics, this is known to be related to the size of the residuals. More accurately, we typically would take the square root of this, and that would estimate the size of the residuals when computing the regression line.